Hey Stats class, here is our first homework question from Chapter 8. So this is 8.1.24. When you're doing your homework, you'll see something similar to this. And our test statistic is given, and we're told that P is equal to 4/7. And we want to see if we would reject or fail to reject this. Okay, now let's think about what happens with these types of tests. When we have these critical values test, this version of a hypothesis test, what we do is we draw the test and we find our claim value. So in this case, that's 4/7. And then our test statistic is when we convert this to a z-score. So remember the mean, the population proportion would be the mean of the distribution of sample proportion. So it would become 0 in the z distribution. Okay, so this is like, the distribution of p hats, 4/7 is in the middle. But when we change them to z-scores, 0 is in the middle. So if I start off, let me draw that back, and 4/7 is in the middle, and it gets transformed to a 0. And then our test statistic is -2.11. The question becomes, is that in our rejection region? And what is our rejection region? Our rejection region is determined by this thing, alpha. But because it's a two-tailed test, and we know it's a two-tailed test because it doesn't talk about greater than or less than in our claim, we have to divide up that alpha into two tails. Okay, so this down here is going to be 0.005, and this up here is going to be 0.005 as well, because if you add those two together, you get 0.01. So two-tailed test, we have to divide this alpha in half. For a left-tailed, right-tailed test, we don't divide it, but for a two-tailed test, we do. So what I'm having to do is I'm trying to find z alpha over 2, which in this case is z.005. Right? And that's one of the things that we can do, these 8.1 spreadsheets. So if I have, let me see if I can pull it in here. This right here, this to get my critical values. So what type of test? It's a two-tailed test. All right, left-tailed, right-tailed, two-tailed. So we got a two-tailed test here, and it gives me z. It says z is -2.11. So if I change this to -2.11, and the significance level alpha is 0.01. All right. What we get, what our critical values are those two right there, -2.58 and +2.58. That's given down here. We're just having to round them. 2.575, so we round up to 2.58, -2.58. So that's where those are coming from. If you're curious to where I'm getting it, just click on this. This is, you don't have to worry about all this stuff, but it's just inverse normal. So the normal inverse feature from those Chapter 6 spreadsheets is where I'm getting it. I can type it in here. It's not that bad to get. It's equals norm dot inverse. And then it's just the area to the left of the value. So like I drew on that picture, the area in each tail was 0.005. So if I did 0.005, and the mean is 0 and standard deviation is 1 because this is z distribution, there's our critical numbers. That's where this number is coming from, and then we just take away the negative for the other one. So it's just the area in the tail, and because it's a two-tailed test, it's half of alpha. Now that we know what those numbers are, I can go back into this, and I know that where these rejection regions, if I fall far enough away from the 0 into these rejection regions, then I'm going to reject the claim that 4/7 is the population proportion. So these two numbers are negative 2.58 and positive 2.58. And where do I fall? What's my test statistic? I'll do it in blue. It's negative 2.11. Let me do it in darker blue. So negative 2.11, that would fall about right there. All right, we've got to get all the way into the rejection region. We've got to get all the way into here before we reject the claim. We didn't fall in there. We didn't get far enough away. So, if we land in these, we'd reject. But if we don't land in these, if we're in this other part, we fail to reject. And that's what we have to do here.